Which question we had to discuss? Anyone having any idea? Okay, tree we did in order pre-order to make the tree node correct. We discussed its optimized solution as well, and you guys said that we have to go through that solution once. So did you went through it? Solution number revised from basic. Okay. Is
I
BST,
did.
I think, yeah, sorry, Vishnu, I didn't heard you.
So I was revising the basic from the beginning. Um, the solution like that you propose, I have not tried yet.
Mm-hmm. Okay. So you can take the weekend time because like Saturday and Sunday there will be off. So you can use or utilize that time and try to do that solution.
Ma'am, one question I have, like, which reference are you following, or which is your favorite for this tree and recursion? Because
Actually, it's like I have my own notes, which is a combination of several other lectures which I visited in the past. Okay, so it's not like I'll say that some specific content I have visited. It's simply like that. It's a combination of so many things I have been through so far. So yeah, I can't give you any specific reference, but I have heard that the Udemy courses are very good these days. So Udemy, probably you can see the data structure courses because I've seen, I don't remember this instructor name, but I'll just check it out and will tell you, because if you know the basics of data structures and you know what tree is, you know what linked list is, soon we are going to learn DP and graph. So if you're aware of the basics, you can easily go through his course because he gives a lot of content, and basically that guy is from Google. So he tells you that what are the questions being asked in the interviews and all. So he gives you a lot of exposure to the industry and basically what questions are being asked in the interviews. So you can go through that content. And like he does not go much into basics or deep topics. It's just like he tells you, okay, this thing should be done in this way. And this is the particular solution to this particular question. That's it. Like we in the class, we discuss the brute force, then we optimize it a little bit, then we ultimately move to the optimized solution. Okay. But every other course you visit or you are going to visit, they are not going to give you this much of a content. Okay. So that's basically a high level kind of learning. So once you're done with this course, you can freely visit those courses. You will be able to understand it.
okay,
Am I clear?
yes, yes.
Okay, perfect. So Vishnu, you can tell me what are the areas you are like. Oh, already I've told you that Saturday we can have a class and we are having a discussion. In that you can freely discuss what are the topics you're facing problem on. Maybe I can try to simplify my explanation a bit more so that you will be able to understand it, and maybe you don't have a problem then.
Okay, thank you.
Okay, others as well, guys. I realize that only like mostly in the class I only see Kishan's and Vishnu's response, so I know, okay, these two people are understanding, not understanding anything, but the remaining are so quiet that I even don't know what you guys are understanding or not. So in on Saturday you have the chance, you can interact with me. You can tell me what are the problems you're facing in this course. You can tell me, okay, ma'am, we have not practiced since this topic. So can you guide us from here? Like what should we do now? Anything you want to discuss, it's like you can be free on Saturday because like right now on weekdays we don't have much time. So on Saturdays you can take the time and you can discuss it with me. Okay. So let's quickly move on to our next question. which was basically to find the length from point A to point B in a tree. Yes. Just a minute. Okay, so I'll just quickly draw. Okay, so let's consider this as an A and let's consider this as an B. We need to find the distance from A till B. Approach we discussed. We need to find the path from A to root. And then you need to find the distance from, okay, I'll just write it in the points. Path from, yeah, A to root. Next is path from B to root. Then the third step is going to be remove the repeating ones. Remove the redundant nodes. Except one. Like when you have just one common node, you need to stop. Okay, so these are the three steps you need to follow. And at the end, find out the length of the path from A to root, find like whatever, and then you will be getting your answer. Clear, everyone? So if dummy, I'll show you. The dummy looks something like you have an array, first array, which will be having, like which will be storing the nodes as, let me name it as x1 and x2. This one will be named as y1, y2, y3. So this will be stored as root, then x2, then x1, and then e. Your br will be stored as root, then y1, y2, y3, and b. My bad, I have, okay, naming is fine. So, yep, this is done and nothing is common you can see except the root, which is required as well. So you will find out the length of AR. You will find out the length of BR. And then you will give its addition as in length. So here you will get it as 7. Should it be 7? Should it be 7?
Yes. Yes. Ma'am, one thing, position of A and B is also to be found out by
Position
that.
of B, obviously you need to find out, right? Like you need to search where is your A and B are lying. How come you will know that?
Yeah, yeah. So that is included in the first and second step.
Yeah, obviously, path from A to root indicates that first you need to figure out where your A is, and then the other things can be done.
Yeah. Okay, I'm good.
Cool. Okay, just a minute. Okay. So now, if you guys are clear with the steps, can you try writing the code for this? Okay. So I'll just quickly open the Eclipse. Any one of you can just help me out. I can help if no. Yeah, you can. Yes. Yes, guys, anyone can unmute and help me out. I'm not gonna write the entire thing. I'll just write the path function. Okay. Is anyone gonna help me?
Yeah.
Okay.
So just if you're writing the path of A to root, then first I have to find the position of A.
Okay.
So the parameter would be the node A, or then the
Just
parameter.
let me share my screen once again, and I'll just show you probably the search function. That will be better. I'm not sure where actually. Okay, so this was the traversal, and
Yeah, before deletion.
this. Right?
Yeah, yeah, yeah. So keep recursing until we find the element.
Okay. So basically, my point here is you will be given already, let's suppose a function path. Okay. In this path function, you will be given root node,
Yeah,
node root, and then next you will be given int a, next you'll
yeah,
be given int b. Okay. This
yeah.
will be given. Then you need to find out, like, let's suppose here you'll be having node root. Oops, my bad.
Then yeah. int a, comma b, int b.
This will be your function statement, which will be given. So what you need to do here, my suggestion, you need to find path one for, let's suppose I'll write find path. Okay. And I'll just pass here root node and I'll pass A. And next I'm going to pass a list along with it. Okay. I will create a list of nodes ls1 equals to new array list of every error that is coming right now. It's because I have not implemented each and everything, but you can try it. Yeah, correct. Individually search the data. So from here, you will fill your, sorry, not in. Yeah, you will fill your ls1. Same thing you're gonna do with ls2.
B as the
Yeah. Yes, Bhuvnesh, you need to create two lists for two link, like two paths. Okay. Okay. So you need to find the path for both of them. You will be getting some list out of it. Then here, some logic should be implemented to remove the common nodes, except one. Once this is done, you can return the length of ls1 plus the length of ls2. Is anyone getting
Yeah, I have a
the
doubt.
idea?
Except one, I am not clear. Like in this case, where the root is common between A and B, we include up till the root. So
No, it's
3 plus
like,
3 plus 4. How we come to 7 is by not excluding the
correct, but root is the only common node in between A and B, right?
yeah.
But what if there are more than one common nodes there?
Yeah, so that many number of common
See
node.
here,
Oh, I got you.
if you take this, the distance from the root, you will get root, then x1, then x2, x3, and A. Getting me?
yeah,
And if you take for B the path, you will get root, then again x1, then y1, y2, and B.
yeah,
Clear? But the common point of intersection between A and B should be x1, not the root.
yeah,
Yes, that's
yeah,
why we are eliminating the common nodes until we are left with just one common node, okay, which is connecting the path between A and B.
yeah,
Clear now?
yeah.
Okay, perfect. Okay, there should be some.
I was also thinking that the length is of the edges is always less by one compared to number of nodes.
Mhm.
So that is also one of the reason why we are excluding one.
No, 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 it's not at all. You can count them here. You have x1 is common, right? So 1, 2, 3, 4, 5, 6, 7, 8. If you count here 1, 2, 3, 4, 5. Sorry, my bad. Yeah, the length is coming as 6. So it's counting 8 till.
X1 common, right? 2 times we need.
Yeah, that's true. But I just counted here for root and it was coming fine. I'm not sure what's happening. See here, I counted from 8 till root. So 1, 2, 3, 4, 5, 6, and 7. Same thing we are getting, right?
So here there is
Here
no
there is
common.
no common.
Sorry?
Common node there, no common node, right?
The root is common, right?
Yeah, root node is common.
The root node is common. And how
But
come? Yeah,
yeah,
sorry.
but length is not common. Like in that there was one intersection.
X1 we need to calculate 2 times.
Getting you.
A, X3, X2,
So
X1, one more X1.
So see, this is removed. Okay, so okay. Um, how come there comes a difference of two numbers here, not even one? Because at least okay, this is fine as well. Hmm. Just a minute. Actually, I have taken it as wrong. It's -2 also, right? Because if here I consider root x2, x1, and a, it should be 4. And here if I consider root y1, y2, y3, and b, it should be 5. Overall,
Correct.
it will be 9. Okay, yeah. Okay, clear. So basically, for getting if getting the correct answer, you can eliminate all the common nodes also. Because if you eliminate the common nodes, it's basically like it's not even getting counted. Nodes are not getting even counted, right? So number of edges you are only counting and you will get your correct answer.
Correct. Yeah.
Clear? So you can eliminate all. I should remove this statement as well. Because practically it seems right, but for the answer basis, it's better this way. Clear,
Yes.
everyone? Okay, perfect. So I have given you a rough idea of how to do this. Can you guys complete it? Obviously, I can tell you if you're not able to like find the path or you have any issues with find path and all, I'll help you out. But right now, can you try to finish this code up? Yes, no,
So just I'm thinking that in order to
no,
get
not right now, not right now. It
okay,
can be tomorrow, by tomorrow.
okay, fine. Yeah.
Okay, so I'll move on to the next question. So you have a tree. You are given the numbers in here. It's just a binary tree, not a binary search tree. Okay. So the question here is you need to find the maximum sum from any of the branches of the tree or any of the path of the tree. It may or may not cross the root node, but you just need to find end to end, like from one leaf node till another leaf node, a path, so that you can get a maximum sum out of it in the entire tree. Is the question clear? Okay, not clear. If I'll pick up, okay, I'll just tell you. If I'll pick up, let's suppose 10 minus 3 minus 1, 6, 5, and minus 3, 12, 18, minus 4, and 7. What is the maximum sum here? No, you have to sum all the values. Positive, negative doesn't matter. You have to sum it up all. Guys, do it quickly and tell me the answer. 47. Okay. Now, next is you just pick up this 7. Seven, then minus 4, 18, 12, minus 2, and 18. How much is the sum? 51. So compared to the previous path I took, okay, 49. Compared to the previous path I took, the current path is giving me more sum value than the previous answer, right? So I should be returning this as my answer. So it's basically like you need to pick up 2 pairs, like every 2 pair of numbers in this entire tree. Like let's suppose I picked up minus 2 and 9. Okay, the path between minus 2 and 9 is only this much. And their sum will be 7. So that is one answer. Then I'll pick along with minus 2. Just a minute. Minus 2, I picked up 6. So from minus 2 till 6, the path is minus 2 plus 9 plus 6. So in this way, you have to consider every pair in the tree, and then you need to figure out, okay, which pair in amongst them is giving you the maximum sum. Path is basically starting from A till B, right? So you need to figure out those A and B pointers such that the path between them is the maximum amongst the tree. Clear, everyone? The question statement is clear? Okay. Somewhat similar to the previous question, right?
No, ma'am. Earlier it was all from the leaf, but here it is anywhere in the middle also. So we have to construct so many subarrays
But
and then
who
add them.
told you that in previous question it is compulsory that A and B should be the leaf nodes?
Okay.
A and B can be any points, right? Like it's never, I never told you that A and B should be leaf nodes and all. Did I?
No.
No.
Okay.
So it's the same.
Okay.
Okay, from one point another, we have to consider total tree and all pairs. Correct. But what will be its complexity? All pairs. Just imagine.
N square because pairs. Then
Okay. For every pair, you need to find the path.
Yeah.
Then
Then remove the redundant. I mean, that's for the previous question, but for this, we
no,
have to
here
find.
also, right? Because let's suppose you are finding out these two numbers, okay, -2 and 9. These are your 2 pointers right now. So if you're going to find the path for them, you will find it from the root node, right? So from
Yeah.
root node, if you find, you will get -3, 5, 6, 9, and -2. In the
Yeah.
path, you will get this. For 9, you will get -3, 5, 6, and 9, correct?
Yeah.
Yeah. So are you going to keep these common nodes?
No.
No, you have to remove them here also. Clear?
Yeah.
So basically n square for every pair. Next is n for finding out the path from till A. Let's suppose one of the point I'm considering as an A. Next n for finding out the path from like till B. And then n to remove the common nodes and basically find out the maximum. If you have to find the sum, then obviously it will take again n time, right?
Yeah.
Yes, you were saying something.
No, ma'am. I have to think a lot about all the three things.
You have to think a lot about. That's why I told you to implement the first question, because once you implement it, then it will become easy, right?
Yes.
Okay, perfect. You all understood this question? Great. So now you first need to solve that question first, the one which I explained right now, and then we will try to implement this question. So this was our ultimate question. Because of that, like because of this question, we picked up the previous question. Clear? Okay. So now there is an optimization to it as well that we are gonna see tomorrow once you are done with your implementation. So please finish your implementation by tomorrow. Okay, so we will discuss another question which is not related to any of these. You have been given a tree. Okay, so this is given you the tree. We all learned about level order traversal, right? Anyone remembers it? Level order. Yes. So now this is gonna be vertical order traversal. Okay. So what happens? This is your vertical level. From 5 it starts. You can see 3 and 4 are colliding with 5, right? Because 4 is also coming to the middle, 3 is also coming to the middle. So those will come in that vertical level. -8 will also come in that level. And that's it. Next is this vertical level. Another one is this. Next one is gonna be, it should cover this. So basically in level order, if you remember, we have like level 0, then level 1, then level 2. But here we call our like level which goes through the root as 0th vertical level. Towards the right hand side, they are positive 0, 1, 2, 3. And towards the left hand side, they are negative. Clear? So it's just like you need to print your binary tree in the form of vertical order traversal. Clear, guys? And you all know that all the numbers in a specific level should be printed together. Okay. You guys want to give it a shot? Need to think, right? Yeah. Okay, so I won't give you much today because I have already given you a homework, the code you have to do. Next is you have to think of this vertical order traversal. So I won't be giving you much today. Just try to think of these and we'll like come tomorrow by doing your work. That's it. I guess almost we are few questions we have left in trees. Then it will be done, I guess, by next Tuesday. And then we will move on to our DP. Okay, now I'll just open that miscellaneous question. So we discussed this, that you have to form a subarray and all. I'm not going to explain today what subarray is at least. Can you find out the subarrays in order of n square time complexity? I told you that day, right? That we can do that. Yes, right. So I guess that concept is clear. So we have our second solution, which has n square. The remaining things will be same. Basically here, instead of using the merge sort, you can try using the insertion sort, okay? Are you guys getting it? So if you use insertion sort here, like every time a number is coming, you have to know, okay?
What I meant is that how will insertion sort come into this picture? That's not clear.
It's basically like you have been given this 3 and -1. Okay. So what you did, you just sorted them like you got 3, you just a minute. You have 3, okay. -1 came, you arranged it over here. Basically, you inserted it before 3. Next, again, next number is gonna come as 5. So you inserted it here. So basically what you are doing, you are just iterating on your given array so far or subarray so far, and you are inserting your current number in its correct position. Are you getting it?
Yeah.
Previously, what we were doing, we had, let's suppose 3, we got another number as -1, next we got as 5. Then what we were doing, we were picking this entire array, then sorting it completely. Next time, if 8 is coming up, let's suppose the next number, again we were picking up this entire array, and then again we were sorting it using the merge sort. Getting it what I'm saying? Yes. So what it was doing, if we are again and again sorting it, it was taking our time as n log n. But since here what we are doing, we are just keeping our array as sorted from the start. So how much time will it take to insert a element in its proper position? Guys, are you able to follow? How much time will it take to insert a number in its proper position? Order of 1? No, because let's
Okay.
suppose, why to insert? We can insert at the end, right? But what if your number is like 2? You have to insert it here, right? We are maintaining a sorted subarray. Yeah, it will be order of n. Then you need to iterate and check if it can form a continuous subarray. And the next thing is you need to maintain a space of n just because you're maintaining a sorted array. Clear? Okay.
Ma'am, I didn't get the space part. Like how this
See,
space?
you are storing this array somewhere, right?
Yeah.
So that is going to take n space.
Okay. Okay.
Clear?
Yeah.
Okay. So you got two solutions, basically 3 solutions to it. Like you can do the entire same thing with n square complexity. Then you got insertion sort part. And now the third solution, basically according to here, is going to be, I'll just, if it is a question where you have to find a subarray which can be rearranged into a continuous subarray or not, basically you have to find the length of that, okay? And there are no duplicates as well. Then let's suppose this was my subarray. Is the sorting compulsory here between 5, 8, 7, 6 to identify if it is continuous or not? Can't there be some other way to find out if they are continuous or not? You guys are getting my hint?
Yeah. I mean, we should sort while we are traversing.
Again, see, sorting, I am saying instead of sorting. Like, I know when you will sort, you will know that it is continuous or not. But my point is, can you do it without sorting? Think of it. Think if you have been given numbers from 1 to 10 randomly, and you need to identify, okay, the numbers are between 9 to 10 only. How will you get it? Sum of n terms. Again, it will take n time. Kishan, and we have already like taken it till end time using the insertion sort, so it won't be helpful, right? What you guys can do, you can find the maximum, you can keep the track of maximum in your subarray, you can keep the track of minimum in your subarray, and you can do max minus min plus 1. So your max here is 8, your min here is 5, plus 1 is gonna be 4. That is, if this particular expression and the length of your given subarray are same, that indicates that your array is continuous. Are you guys able to follow? And it is only happening because there are no duplicates. If there would have been duplicates, it can arise some problem. Clear? So basically what we have done now, the internal n part, we are just removing it, right? N square is here. N will take to find out the maximum and minimum in the given subarray. Okay, like right now, if you will like, you have the subarray, you will iterate on that subarray and find the minimum and maximum. It will take n time plus 1 to for this expression, and there will be obviously no space required. Next solution to it is, now it's n cube. Next solution for this can be, you can calculate your minimum and maximum on the fly. That is, you found your first subarray, you know your minimum and maximum, update it. You go to your next subarray, update your minimum and maximum, go to next subarray, update your minimum and maximum. Similarly, basically it's like you're not recalculating your minimum and maximum again and again. Guys, are you able to follow? I'm like continuously telling you the solutions and solutions and solutions. Are you guys able to follow it? Or is it too hectic? Last, see, Kishan, you get it? Like we find out a subarray, we will iterate on it and find minimum and find maximum. Correct. My point is, you got your subarray 3 from the start. You find your minimum and maximum here only. Update your min and max with this number. You found your next subarray 3 and minus 1. Again, see if the coming number is maximum, update your max. If it's minimum, update your min. Then 5 is coming, again see if it is max, update your max. If it is min, update your min. So what is happening now? Every time we are not forming a subarray and then we are recalculating its minimum and maximum. On the fly, we are just seeing the number we are getting is max or min, and we are updating it accordingly. Are you guys able to follow it now?
Yeah, ma'am, I'm following that, but I have one question, like if it won't help in finding out the continuous array, like one is
Why
1,
it
one
won't?
is 100.
Sorry?
And supposing there's first element is first, and after 3 elements it is 100.
Okay.
Our goal is to find out continuous array.
Yeah.
So we are just having max and min as like very high and low numbers, but we are not getting to the point of continuous array.
The thing is, you're saying here it's 100, right?
Yeah, somewhere in the middle is 100.
Okay, you
And
got 100. Okay.
there are a lot
Here,
of
instead of 8, you got 100. Okay.
correct, yeah.
Then,
So our goal is length of the longest subarray.
right. So now will it form like 3 and minus 1? Will it form 3 will form longest subarray, longest continuous subarray? Okay, 3 right now will give you the answer as 1. It is.
Correct.
3 and
Oh, yeah.
minus 1 are is it continuous?
No.
3 minus 1 and 5.
No.
3 minus 1, 5 and 8. Sorry, 5 and 100.
No.
No. 3 minus 5 minus 1, 5, 107.
Yeah. So in this way,
Huh?
we'll end up
Yeah.
getting more subarrays like that. Yeah.
Basically, it's like now in the entire array, starting with 3, you're not going to get any continuous subarray
Yeah.
because 100 has come in the between.
Yeah.
When you start with minus 1, again, it's going to be the same.
Yeah.
When you start with 5, again, it's going to be the same.
Yeah.
With 100, again, it's going to be the same.
Same. Yeah.
But when 100 is skipped, you start counting your subarrays from here.
Mm.
Then there are chances you're going to get your maximum length continuous subarray, right?
Yeah.
Yeah, that's point I'm saying.
Okay.
Try to implement this solution. It's very easy. I have made it very easy now. You just need to find out your subarrays, and that's it. 1 plus 1, this happened, and this also 1. So the time complexity, which was reaching around n to the power 4 log n, has now become n square. Guys, are you clear? So try to implement. Those who has a lot of time, try to go through all of these. Otherwise, I'll just recommend try to implement this one and this one, and you will be done. Yeah, insertion sort 1. Correct. Okay. Any questions in this? Okay. So I'll just close the class for today. We'll see you guys tomorrow. So similar to this, there are lots of miscellaneous questions which we will discuss, and they are really interesting. Okay, guys. Thank you.
Thank you.